Hi everyone, in today's lesson we're going to talk about how to find limits using a table of values. So first I want to review how to find a limit graphically. So given f of x equals this function, find the following limit graphically. So here's the graph of this function. So I want to find the limit as x approaches 3. But remember, in order to do that, I have to check the limit from the right equals the limit from the left. So let's see. The limit from the left looks like it's going to be 6, and the limit from the right looks like it's also going to be 6. So now that I've verified that the limit from the left is equal to the limit from the right, we can say the limit as x approaches 3 is just 6. So now I'd like to show you how we could use a table of values to find that limit. Sometimes we may not be given a graph at all, and we may need to just rely on a table to find the limit. So the same question, but now using tables. So given this function, find the limit as x approaches 3 using the table below. So this is kind of like a table of values, but what I'm doing is I want to see the behavior of the graph as x gets closer and closer to 3 from the left and from the right. So I want you to think of a number line. I want to find the limit as x approaches 3. So obviously this is where 4 would be and this is where 2 would be. So we're going to try to be as close to this 3 as possible. So we could say numbers like 3.0001. We could say 3.001 or even 3.01. We're just getting a little bit further away each time. Or we could say a little bit closer to 3 on the left side. We could say this is about 2.9999 and then so on and so on. So that's what I'm doing. I want to see what happens to the behavior when I get really close to 3 from the left and really close to 3 from the right. So what I want to do is I want to start by plugging in an x value into this function. So if I plug in 2.99 for every x, that's what I'm going to do here. So it's going to be 2.99 squared minus 9 over 2.99 minus 3. Alright, so what I'd like you to do now is plug this into the calculator using alpha y equals, and then hit resume when you're ready for the answer. Okay, I got 5.99. So that's what I'm going to put here. So by throwing this number, 2.99, into the x, I found that f of x was 5.99. So I can go ahead and put that here. Now, I'm not going to waste your time plugging things in. I've already done it for you. So I've plugged in the next number, 2.999, into x squared minus 9 over x minus 3. And I got 5.999. So 5.999. And then I tried plugging in 2.999 into all x's. And I got 5.9999. Now we're going to do the same thing from the right-hand side. So I want to start with the furthermost one away, 3.01. So we're going to plug in 3.01 squared minus 9 over 3.01 minus 3. So go ahead, type that into the calculator and hit resume when you're ready. Okay, I got about 6.01. So when x is 3.01, y is 6.01. And again, I'm not going to have you do this again, but I already plugged in f of 3.001, and I got 6.001. And then the next one I got was 6.0001. So I want you to use this table to now define the limit. So look, as x is getting closer to 3, it looks like y is getting closer and closer to 6. Now, as x is getting closer to 3 from the right, it looks like the number is getting closer and closer to 6, more and more accurate. So technically, we could say the limit as x approaches 3 of f of x is 6. Now, technically I really shouldn't put this 6 here because we're saying what is the value at x is 3. What is the y value? Technically, the answer is does not exist. Technically, there is no value here. And here's the reason why. If I were to plug in 3 into this graph, look what happens. 3 squared minus 9 over 3 minus 3. 3 squared is 9, minus 9 is 0 over 0, which is undefined. So the graph is undefined at this point. Or in other words, it has a hole or an asymptote. So look, there's a hole here. So the graph does not have a value there. So when x is 3, the graph does not exist. But the limit does. It approaches 6, but may or may not reach it. So we can use this table of values to say, look, it's coming close to 6, but it may or may not touch it. That's why we say the limit as x approaches 3 is in fact 6. Okay, let's try another example. Okay, so now I have a piecewise function. I have a function made up of 2 different pieces. I have the line y equals 4 when x is less than or equal to 1, and I have the parabola y equals x squared when x is greater than 1. So here's half of my parabola and here's half of my line. So I want to calculate 2 limits. Let's first calculate them graphically and prove them using a table. So I want to find the limit as x approaches 2. Now remember, I have to check the left and the right hand limits. So when x approaches 2 from the left, it looks like I'm at 4. And when x approaches 2 from the right, it looks like I'm also at 4. So this limit exists. The limit is 4. It looks as though the limit as x approaches 2 from the right is equal to 4, and so is the limit as x approaches 2 from the left. So let's see what happens with the limit as we approach 1. So let's look at the limit. Let's write it down first. The limit as x approaches 1 from the right, and let's look at the limit as x approaches 1 from the left. So here's 1. So from the left, or excuse me, from the right, I'm going to use this graph, and it looks like the limit is 1. And when I approach the graph from the left, it looks like it's approaching 1. Oh, excuse me, looks like it's approaching 4. So the limit from the left actually does not equal the limit from the right. So this limit does not exist. So let's see if we could prove these 2 things using the tables. So what I'd like you to do is take a look at the piecewise function here. And I want to look at the graph as x approaches 2. So which side of the graph am I going to look at? Am I going to look at the x squared or am I going to look at the 4? And you actually should be telling me x squared because 2 is greater than 1, right? So it would fall under this category. So look what I did here. I did 1.999 squared, and I got this. 1.999 squared, I got this. So I want you to fill out what this should be and what this should be, and then fill out the chart and see if you can find the limit, and then hit resume when you're ready. Okay, so these are the numbers that I got when I did 1.99 squared. I got 3.96 if I rounded to the nearest hundredth, and this one I got 4.04. So 4.04, 4.004, 4.0004, 3.96, 3.996, and 3.9996. So look, as the graph is approaching 2 from the left, it looks like this number is increasing and increasing and increasing and getting close to 4. And as we go back from the right, it looks like it's getting closer to 4 as well. So let's actually see what the value of 2 is. So we can go ahead and plug 2 into this bottom piece. So if we do that, we get 2 squared, and that equals 4. So this proves that the graph is actually defined at that value, and that limit is actually 4. And that's what we got when we did it up here. So now let's see if we could do the next example as x approaches 1. So what we're going to try to do is prove that the limit does not exist. So let's see if we could do that. So when we want to prove that the limit does not exist, we want to see the limit as x approaches 1. So notice this is where x is less than or equal to 1. So if it's equal to 1, it's going to be 4 every single time. So that's why I have 4s everywhere. So let's see what we would fill in here. 4, 4, and 4, right? Every number is going to be 4 if it is less than or equal to 1. So even the 1 will work, right? That'll all be 4. But what if I begin to be greater than 1, like 1.0001 or 1.001? I'm now greater than 1, so I have to use the x squared graph. So I want to type in 1.01 squared. And if you do that, you should get 1.02 approximately. Okay? So 1.02, 1.002, and 1.0002. So it looks like the limit from the right is going towards 1, and the limit to the left is going towards 4. So the limit from the left is going to 4, the limit from the right is going to 1. So therefore, when the value of the function at 1 is 4, but the two limits aren't equal, therefore the limit as x approaches 1 does not exist. Okay? So today's lesson was really just all about charts and tables and proving to you that they have the same limits graphically. So if you have any questions, please jot them down and we will go over all of this tomorrow in class. All right, thanks. Have a good night.